Okay, so the next group of compounds we want to discuss are known as esters. So unfortunately, in the word ester, there's nothing to underline to give us a hint on how to name these. So let's look at what an ester looks like. Okay, so an ester has this typical form: a carbon chain, a carbon double bonded to an oxygen with an O adjacent to it. Okay, so if this oxygen is here, it's an ester. If this were a hydrogen, it would be an aldehyde. If this were a carbon chain, it would be a ketone. Okay, so all three of those molecules have the common carbonyl group there. Okay, so this is how we recognize it's an ester. Now let's go ahead and name a few, kind of learning by doing. Before we do that, one important thing to note about esters: esters are responsible for the majority of smells of fruits and flowers. Most of the pleasant nature smells that we experience result from esters. So if you take my senior level class, we'll actually make some esters. Okay, so you can synthetically in lab produce the molecule that is responsible for the smell of apples. Okay, so if you make it in lab, it is a synthetic molecule by label, but it is equivalent to the molecule that would naturally occur in apples and give that scent, for example. Okay, so that's a side note. Let's go ahead and jump into naming. So let's look at this first molecule. Okay. So hopefully we recognize that's an ester. So these are a little bit tricky to name. We might want to write out some steps for these actually. Okay. So first, let's say name the carbon chain bonded to the oxygen. Okay. So the second step we'll write is, let's say, space. Okay. So we leave a space in the name. The third step is name the other carbon chain. And 4, we'll apply the OATE ending. Okay. So whereas before for aldehydes, ketones, esters, alcohols, there were some letters in the name that we used to name compounds, but it's not true for esters. Esters will end in OATE. So let's follow the steps here. Let's go ahead and name the carbon chain bonded to the oxygen. Okay, so that is a 1 carbon chain. Okay, so we call it methyl. Okay, so we leave the YL here. We leave a space. We name the longer carbon chain: 1, 2, 3, 4. So I say BUT. There are only carbon-carbon single bonds, so I say AN. Then I apply the OATE ending, OATE. So methyl butanoate. Okay? So this is the molecule responsible for the apple smell. Okay? So this is why apples smell like what we consider to be apples today. So let's look at another one. Let's look at work our steps here and name the carbon chain bonded to the oxygen. 1, 2 carbons, that's an ethyl. I'll leave a space, the longer carbon chain, and it's not necessarily this one is always longer. Okay, this one could be longer. You just look at which one's bonded to the oxygen. So name this carbon chain 1, 2, 3, 4. So it's still BUT. There are only carbon-carbon single bonds, so it's AN, and apply the ending OATE. So ethyl butanoate. Ethyl butanoate is one of the molecules responsible for the scent of pineapples, actually. So let's look at one that I draw in the opposite direction. Okay. So this one is different for 2 reasons. Now the molecule's flipped backwards, which shouldn't change anything for us. But now the carbon chain on the oxygen is longer than the other carbon chain. That changes nothing. Okay, so for the naming, we're only concerned about the location of the carbon chains, not the length necessarily for the steps. So follow our steps still. Let's name the carbon chain attached to the oxygen. 1, 2, 3, 4. Okay, so that's butyl. Space, name the other carbon chain. 1, 2, 3. So that's prop. It's only carbon-carbon single bonds, so it's propan. Then I add the ending OATE. Okay, so butyl propanoate. So let's try one more together. Also, one thing to point out, don't forget to count this carbon, okay? So that was a 1, 2, 3, 4 carbon chain. A 1, 2, 3, 4 carbon chain. A 1, 2, 3 carbon chain. It's easy to forget to count that carbon, so don't forget about that one. Let's go ahead and name this last one together. So I start off by naming the carbon chain attached to the oxygen, so ethyl, space, name the other carbon chain, 1, 2, 3, 4, 5, 6, 7, 8 carbons, so OCT, only carbon-carbon single bonds, so AN, then I add the ending OATE, so ethyl octanoate. So let's try one or two going in the opposite direction, so I could give you methyl, sorry, let me try again, methyl ethanoate. Wow, I'm struggling. Let me try that one more time. I can't write today. So methyl space ETHANOATE. So there we go. So it doesn't matter which way you draw your molecule. You can flip it like this or like this. I tend to draw the oxygen on the right, so if you flip your molecule, that's perfectly okay. So the first thing we have to do is recognize if it ends in OATE that it's an ester, okay? So I have this general structure. And so that's what I start off with. And I know I'm going to have that. So now, how many carbons should be on the oxygen? I have 1 carbon on the oxygen, so I have methyl. Okay? The other carbon chain should be how many carbons? I look at this prefix, F. F is 2 carbons. So that's my structure. So I'm done. Let's go back and double check ourselves. It ends in OATE. Is it an ester? Yes. Okay. Is the carbon chain on the oxygen, does it contain only 1 carbon? Yes. Does the other carbon chain contain 2 carbons? Yes. So we're in good shape. So let's try one more of those. So let's try propyl hexanoate. Okay. So let's start off with the prefix out in front. So first I have to recognize it's an ester. So let's say that first. Then I recognize the prefix out in front. I should have 3 carbons on the oxygen, 1, 2, 3 for propyl. Then I have a 6 carbon chain on the other side. So there's 1, 2, 3, 4, 5, 6. Go back and double check myself. OATE means it's an ester. AN means only carbon-carbon single bonds. Hex means there's 1, 2, 3, 4, 5, 6 carbon chain. Then propyl tells me there's a 3 carbon chain on the oxygen, so I'm in good shape there. So it's good to make the habit of when you're done, do what I just did. Go back and break the name down again and make sure your name matches up with the structure. So if you had drawn this, so 1, 2, 3, 4, 5, 6, that is the exact same structure. Okay, so these are identical molecules. I just happen to flip one in the opposite direction. So if you don't see that, I'll look at it for a second and try in your mind to envision flipping it. If you can't do that, go ahead and try and name this, and you'll find when you name it, you see that it is in fact propyl hexanoate. So those are the basic rules for naming esters and drawing their structures.